Once dismissed as a low-grade frozen food, fish sticks have undergone a remarkable transformation, with more than 25 billion sticks consumed every year, becoming an iconic example of modern eating. Fast, cheap, yet still delicious. But how are more than 3 million tons of fish sticks produced annually? The journey to conquer global taste buds begins in some of the harshest oceans on Earth, where millions of tons of pollock, the golden ingredient powering this billion-dollar industry, are hauled aboard. Once the holds are full, processing begins instantly, handling hundreds of fish per minute to create standardized fillets, which are then refined in advanced factories into perfectly crispy, perfectly uniform fish sticks. In today's video, join Agriculture Insight as we explore the massive production system behind the scenes and the secrets that give this convenient food its enduring appeal. Everything will be revealed right now. Do you like fish sticks? Yes or no, of course. But for hundreds of millions of people in the United States, the UK, Germany, and many European countries, fish sticks have gone far beyond a simple convenience food, becoming a staple of family meals, school menus, and mainstream food culture. In the UK alone, the birthplace of fish fingers, 75% of children eat fish sticks before ever tasting fresh fish for the first time. Back in the 1950s, when Gorton's launched the fish stick as a lifesaver for mountains of frozen seafood inventory, the product was considered hard to swallow, and almost nobody wanted to buy it. Yet only a few years later, its sales exploded to the point that it once threatened even the throne of canned meat in the world of industrial food. Today, with a near GOAT status in the frozen food industry, fish sticks generate more than $3 billion USD a year and continue expanding their influence globally. Many people confuse the taste of fish sticks with chicken nuggets, but in terms of nutritional value, fish sticks clearly come out on top thanks to their richness in omega-3, low saturated fat, and virtually no added sugar. Meanwhile, compared to imitation crab sticks, fish sticks earn even more points because they are made from real pollock fillets, preserving their natural flavor and firmer texture. And every journey needs a starting point. For fish sticks, it all begins in the Bering Sea, one of the coldest and harshest waters on the planet, yet a strategic resource hub for the global fish stick industry. Lying between Alaska and Russia, the Bering is a harsh natural boundary connecting the Pacific Ocean with the Arctic Ocean. This is a deep, cold body of water constantly struck by strong winds, drifting ice, and fierce winter storms, making it one of the most challenging fishing grounds in the world. Yet this very harshness nurtures a nutrient-rich ecosystem, where diversity and dense biological productivity turn the Bering into a rare natural reserve of seafood, allowing migratory species, especially Alaska pollock, to reach immense stock levels. Although there are hundreds of fish species offshore, fish sticks in fact revolve around only a few main names, of which Alaska pollock accounts for up to 90%. The rest are hake, cod, and haddock. All of them are white meat fish, low in bones, easy to fillet, and cheap enough to meet an annual output of millions of tons. Every January, the Bering Sea boils with modern factory trawlers more than 113 meters long, with capacities of up to 6,000 horsepower, where seasoned fishermen are ready to conquer migratory fish schools, numbering in the billions. Modern fishing has become a game of technology, completely beyond the realm of luck. Natural signs such as flocks of seagulls swooping down to the water, once the familiar code fishermen used to guess the location of fish schools, are no longer the only tools for tracking the traces of massive migratory fish. Replacing them are deep-scan sonar systems, surface radars, and high-frequency echo sounders, creating a living map of the underwater world in real time. On deck, specialists constantly monitor wave-scan displays and ultrasonic detectors, devices sensitive enough to accurately outline every movement of entire fish schools hidden deep below the seafloor. When the image appears, with dark bands sweeping across the screen like a living cloud of the ocean, the captain immediately orders the nets to be released. Midwater trawl nets, the ultimate weapon of the modern industrial fishing industry, are deployed with near-perfect precision. With a mouth diameter hundreds of meters wide and a height equivalent to a 10-story building, the net is released, opening like a giant steel funnel in the ocean. When the net closes, the entire fish school is gathered in an instant. The bottom of the net is tightened by a cable system, sealed as if tying the mouth of a bag, then slowly hauled to the surface. The back-breaking work of net hauling in the past has now been replaced by automatic hydraulic winches that pull up hundreds of tons of fish with just a single control button, not only saving labor, but also increasing productivity and output by hundreds of times. Within minutes, hundreds of tons of pollock thundered down onto the deck, powerful like the discharge of a dam. On the processing floor, the intake funnels open wide to catch the dense stream of fish flowing straight into the ship's hold, where a floating factory is already waiting to begin a mass processing sequence for the newly captured haul. Inside modern factory trawlers stretching over 100 meters, nearly 3/4 of the space is dedicated to processing and freezing, turning them into true floating factories capable of handling up to 300 tons of fish per trip. The moment the catch hits the deck, a race against time begins. Pollock must be processed within minutes to preserve optimal freshness. From the intake chute, the fish move on to the conveyor system, where a stream of water continuously washes away blood, debris, and surface mucus before they are routed into automatic grading channels based on size, weight, and body shape. At each sorting gate, fish drivers stand by, guiding the flow into the correct processing lanes to prevent blockages and maintain uninterrupted throughput. After grading, the fish are sent to the automatic gutting machine, where a high-speed rotating blade slices along the body, removing the viscera in just a few seconds per fish. Next, the head-body bone separation system operates continuously, processing more than 100 fish per minute. This workflow ensures that the resulting fillets are almost completely free of fine bones, an essential requirement for fish stick production. The fillets then move on to the candling stage. Each piece is examined under intense light from an illuminated table to reveal any remaining bones, blood spots, or tissue defects. Skilled workers at the candling stations quickly remove these small imperfections, a seemingly minor step, yet one that ultimately determines the final quality of the fish block. The qualified fillets are then packed into rectangular fish blocks, weighing approximately 7 to 9 kilograms, with uniform flesh density and precise thickness. This is the standardized raw format that allows hundreds of perfectly identical fish sticks to be cut later on. The blocks are fed into a plate freezer, a dual-surface freezing system using high-pressure steel plates. The core temperature drops within just 2 hours, forming ultrafine ice crystals that preserve muscle structure and minimize moisture loss during thawing. This is a decisive advantage for quality when the blocks are brought ashore for further processing. The vessel's cold hold stores hundreds of tons of fish blocks throughout the voyage, ensuring no thermal loss even as the ship operates continuously for weeks. The long journey at sea for these frozen fillet blocks officially ends when they are brought ashore and sent directly to the fish stick processing plant, the final and most demanding stage in the production of this convenient food. At the plant, each received fish block undergoes a strict incoming quality check. Specialists measure the block's dimensions and weight, verify core temperature, flesh uniformity, color, and moisture loss. A sample block is partially thawed to assess texture, odor, and any remaining pin bones, ensuring the material meets all standards before entering production. After passing the inspection, the fish blocks are moved to the slicing area, the first step, and the one that defines the overall structure in the production of fish sticks. On the slicing line, the frozen fillet blocks are fed through a high-speed bandsaw, dividing them into fillet sheets of uniform thickness before the automatic cutting system takes over and slices them into hundreds of sticks with millimeter-level precision, 10 to 12 millimeters thick, 20 to 25 millimeters wide, and 60 to 90 millimeters long. This exacting precision is essential for achieving perfect consistency in the subsequent coating, frying, and freezing stages. Once shaped, the fish sticks move into the coating line, where their crust is built through 3 consecutive layers that define the final crisp texture. First, each freshly cut stick is completely covered with a thin layer of batter, ensuring even adhesion from end to end. Next, the sticks pass through a dry coating layer, which stabilizes the surface and creates a firm base for the final stage. A generous coating of golden breadcrumbs that will produce the signature light, crunchy bite after frying. Throughout the process, sensor-controlled spraying and rolling systems closely monitor and maintain the optimal coating thickness, ensuring that every finished fish stick expands evenly, fries to a uniform crispness, and achieves consistent quality across the entire batch. After coating, the fish sticks are quickly fried for no more than 30 seconds. This par-frying technique sets the outer crust while keeping the interior frozen. The goal is not to cook the product, but to lock in its shape, ensuring each stick remains intact during freezing and transport. When a fish stick snaps with a crisp break, while the interior remains firm and white, the par-fry level is considered perfect. Immediately after the par-fry stage, the fish sticks enter the IQF system, individual quick freezing. Powerful blasts of ultra-cold air freeze each stick solid within just a few minutes. During the process, the sticks remain separated, preventing any clumping. IQF technology ensures not only free-flowing products but also preserves the muscle structure, moisture content, and overall quality throughout storage and transport. Once the freezing stage is complete, each fish stick moves into the automated packaging area, the final step before leaving the production line. Here, the sticks are checked for weight using high-precision laser sensors, then transferred directly into a fully robotized packing system. Robotic arms handle the arranging, positioning, and sealing of bags or cartons at a steady pace, allowing the line to reach a capacity of 4,000 to 6,000 boxes per hour, depending on the plant configuration. After packaging, the entire batch is moved into the cold storage area, where it waits for distribution across the globe while maintaining its original quality. From the vast Pollock schools of the Bering Sea to the deep freeze precision of processing lines, each stick represents a blend of natural nutrition and carefully controlled technology. But like all industrial foods, it carries its limits. The added batter, oil, and sodium call for mindful selection and moderate consumption. When used wisely, the fish stick becomes more than a quick meal. It becomes a balanced part of contemporary eating, where flavor, nourishment, and responsibility toward our own bodies are meant to coexist. So famous that many people mistake all canned meat for Spam. This product is, in fact, a proprietary brand of canned pork by Hormel Foods, a long-established food corporation headquartered in Minnesota, USA. The story begins in the late 1920s, when J. Hormel, the son of founder George A. Hormel, took over the company during a time when America was in crisis, with widespread unemployment and food shortages. This sparked an urgent demand for affordable, convenient, and long-lasting sources of protein. One day, faced with a surplus of unsold pork shoulder, Jay came up with a bold idea: to transform this cut of meat into a ready-to-eat canned product that could be preserved for long periods and sold directly to consumers. After numerous trials, Spam was officially born in 1937, marking a new era in convenient food. But it wasn't until World War II that Spam truly became a global phenomenon. With a shelf life of up to 5 years without the need for refrigeration or chemical preservatives, and being energy-rich, Spam became a staple in the rations of American soldiers, with tens of thousands of tons shipped to the front lines. Soldiers even found creative uses for Spam fat, lubricating guns or waterproofing boots. Through the military, Spam was introduced to various parts of the world, including Hawaii, Guam, and South Korea. From wartime rations to a global culinary icon, Spam has endured for nearly a century without losing its place in the hearts of consumers. But no matter how legendary the journey, every story has its beginning. And now, let's return to where it all started, with the pig farms where carefully raised and selected livestock provided the very foundation for this canned legend. Everything begins with generations of piglets that are meticulously cared for from the moment they are in the womb. The gestation period lasts about 114 days, during which sows are treated like queens, bathed, monitored for nutrition, and housed in special farrowing pens to ensure absolute safety. Each litter can produce between 10 to 14 piglets, and the mother stays with her young during the first weeks of life, laying the foundation for high-quality meat in the future. Piglets need to nurse for about 3 to 4 weeks. In the first days after birth, their mother's milk contains colostrum, a nutrient-rich substance packed with antibodies that strengthens the immune system and supports healthy development. After weaning, the piglets transition to solid food and are moved to group pens, each housing around 50 pigs. Here, they are fed industrial feed, supplemented with nutrients to promote rapid growth. On average, pigs gain about 10 kilograms per month. They continue to be fattened for another 3 to 4 months, during which their bodies grow so rapidly that they become disproportionate, barely able to move, spending most of their time lying down and drinking water. Their lives revolve around eating and sleeping. Once they reach the target age and weight, about 100 kilograms, they are ready to leave the pens and become cuts of delicious pork. Once the pigs meet the required quality standards, they are carefully moved to the holding area, where they wait to be transported to the processing facility. A truck arrives at the farm to collect the pigs. First, the truck's floor is lowered to form a safe ramp, allowing the pigs to walk up easily. Next, the floor of the truck is covered with straw or fine sand to help the pigs maintain their footing and avoid injury during transport. The pigs are guided through a fenced walkway to ensure their safety and prevent them from scattering. Handlers use lightweight boards or guiding panels to gently direct the pigs onto the truck in an orderly manner. Once inside, the pigs are arranged in a stable position and secured to minimize the risk of injury while in transit. Each truck can carry between 100 and 150 pigs. And when everything is ready, the trucks roll out, marking the beginning of a brand new journey to the pork processing plant. Upon arrival at the processing plant, the pigs are brought into a resting area equipped with ventilation systems, automatic misting, and a continuous supply of clean drinking water. This phase helps reduce stress and allows the muscles to relax. Before entering the processing stage, the pigs are moved into an automated stunning system designed to ensure a smooth and stress-free procedure. Today, 2 common stunning methods used in modern meat processing facilities are carbon dioxide, CO2 stunning, and electrical stunning. Among them, CO2 stunning is more widely used due to its gentler effect and longer duration of unconsciousness. The pigs are placed in a sealed chamber where gradually increasing concentrations of CO2 induce unconsciousness within about 30 seconds. In contrast, electrical stunning uses a current of 240 volts to 400 volts applied directly to the brain, rendering the pig instantly unconscious. While this method is quick, it requires precise handling to ensure effectiveness and animal welfare. The next step is the cleaning process, where each carcass is passed through a hot water scalding system. For several minutes, the water is maintained at a temperature of 58 to 62 degrees Celsius, which helps open up the hair follicles and facilitates faster, more efficient cleaning. Following this, high-precision automatic dehairing machines take over. Soft rubber-coated rotating rollers gently remove the hair without damaging the surface of the skin. Once thoroughly cleaned, the carcass moves on to the singeing area, where intense flames burn off any remaining fine hairs while simultaneously sterilizing the surface. Finally, the internal organs and any inedible parts are completely removed, leaving behind only the clean, white carcass, ready for the trimming stage in the journey toward becoming a high-quality can of Spam. Continuing the process, the clean white carcasses are moved to the cutting area, where different sections of meat are separated based on their intended use. An automated bandsaw system splits each carcass lengthwise from the neck to the tail. In modern facilities, 3D scanning technology is integrated to determine the optimal cutting path, ensuring uniform size and weight between the two halves. This not only maximizes yield, but also facilitates the efficient separation of different meat cuts in subsequent stages. After splitting, each section of meat is cooled and stored at a temperature of approximately 0 to 4 degrees Celsius to preserve freshness and inhibit bacterial growth until it is transported to processing plants. While premium cuts like loin, ribs, and ham are sent to production lines for fresh or high-end frozen products, pork shoulder, often considered a tougher, fattier byproduct, is carefully selected to become the key ingredient in the iconic cans of Spam. At the Spam production facility, carefully selected pork shoulder cuts are sent to the trimming line, where tough tissues, skin, and excess fat are removed, leaving only the most balanced portions of lean and fat. And from this point forward, the pork shoulder begins to shine. Under Hormel's expertise, and with the aid of advanced blending and sterilization technologies, the pork shoulder is revived into a perfect ingredient. Tender, mildly fatty, able to hold its texture after cooking, and ideal for forming into the firm, iconic block inside each can. Pork shoulder not only offers ideal binding properties when ground and mixed with spices, but also gives Spam its signature texture, firm yet sliceable, without crumbling or falling apart. This is the secret behind the distinctive, springy chew, rich flavor, smooth finish that only Spam delivers. And it's the reason why this product has remained beloved around the world for nearly a century. Before entering the mixing stage, the trimmed pork shoulder undergoes coarse grinding using industrial machines. This process doesn't fully puree the meat but preserves a certain fiber structure, an essential factor in giving Spam its firm, cohesive texture, while still feeling like real meat. This is a key distinction from sausages, which require the meat to be finely ground to achieve a smooth consistency. The controlled coarse grinding step plays a crucial role in forming the tightly packed meat texture that consumers experience when slicing into Spam. No crumbling, no mushiness, just a firm, uniform cut every time. After trimming, the pork shoulder is sent to the mixing area, where Spam's proprietary formula comes into play. It includes just a few simple ingredients: pork shoulder, salt, sugar, water, potato starch, and sodium nitrite. The perfect balance of these components creates Spam's signature flavor and texture. The mixture is blended in a chilled environment to maintain freshness, enhance binding, and ensure uniformity, ready for the canning stage. Once mixing is complete, the meat blend is filled into cans, vacuum sealed, and hermetically closed to preserve structure and prepare for sterilization. Spam is cooked directly in the can using high-pressure steam at 121 degrees C for 75 minutes, eliminating microorganisms and allowing shelf life of up to 5 years without added preservatives. Following the cooling and quality inspection process, each can receives the iconic navy blue label with the bold yellow Spam logo, a globally recognized symbol. The finished product is then boxed and shipped to more than 44 countries, completing the journey of one of the world's most iconic food items. Though it may seem like a simple canned meat, Spam has transcended its role as food to become a cultural icon in many countries. In the United States, beyond its association with wartime memories, Spam has made its way into film, television, and music, most notably in Monty Python's musical Spamalot, reflecting its deep influence on popular culture. In Hawaii, Spam is an essential part of the local food culture. With over 7 million cans consumed annually by a population of just over 1 million, it features in beloved dishes like Spam musubi, fried rice, and breakfast platters. Residents even host an annual festival called Waikiki Spam Jam, drawing tens of thousands of attendees to celebrate this familiar food. Meanwhile, in South Korea, Spam is considered a premium gift during major holidays, symbolizing thoughtfulness and prosperity. From overlooked cuts of pork shoulder to a carefully selected, blended, canned, and sterilized product, Spam is far more than just a canned meat. It is a global culinary icon. It represents smart resourcefulness, advanced food processing technology, and a lasting value that has connected with millions of people for nearly a century. Before the 19th century, when refrigeration was still a distant dream, preserving fresh milk was nearly impossible. Until 1856, when American inventor Gale Borden, driven by a sweet mission, created the secret formula that allowed milk to be stored for years in tin cans without cooling, opening the door to an industry now worth over 10 billion USD. Once a strategic ration in world wars, condensed milk today crowns the United States as the global leader with more than 700,000 tons produced annually by giants like Nestlé and Borden Dairy, while the Netherlands holds the title of the heart of Europe, combining large-scale production with a role as a global export hub. Compared to perishable fresh milk, condensed milk stands out for its long shelf life and affordability, while still retaining essential proteins, calcium, and vitamins. Yet, with its high sugar content, it remains both a vital energy bomb in times of scarcity and a product requiring moderation in modern diets. And like every great journey, it all begins at the source. Let us return to the very birthplace of billions of cans of condensed milk, the dairy farm, where the story starts with the harvest of pure, fresh milk. But do you know how to create rich and nutritious drops of milk? The secret lies in the cow's diet, which starts with lush green pastures, a plentiful source of nutrients that keeps the cows healthy and helps them produce high-quality milk. Out in the vast fields, specialized grass-cutting machines work tirelessly, slicing through rows of grass with precision and efficiency. These machines can mow dozens of hectares of grass per hour, cutting it evenly and at the right height to allow for quick regrowth. After the grass is harvested and ensiled, ensuring high-quality milk begins with prioritizing the health and comfort of dairy cows, with nutrition remaining the most critical factor. Their diet is carefully formulated to balance hay, silage corn, straw, and energy-rich grains, supplemented with soybeans, minerals, and vitamins. All of these ingredients are blended in a total mixed ration machine to guarantee that every cow receives the nutrients needed for optimal milk production. On average, they consume about 3 to 4% of their body weight in dry matter daily, meaning a 600-kilogram adult cow may eat up to 20 to 25 kilograms of feed, along with 80 to 120 liters of water to support milk secretion. Once nutrition is secured, the next crucial factor in producing high-quality milk is ensuring the health and comfort of the cows. Many farms even install roller-style massage brushes. When a cow approaches, the brush automatically rotates, cleaning off dust while relaxing muscles and improving blood circulation. Some facilities go further by playing classical or soft music in the barns, creating a calm environment that reduces stress and helps boost milk yield. And as the herd grows, the precise data recorded by electronic chips attached to their ears or collars also helps farmers determine the optimal time for breeding, ensuring successful reproduction and sustaining the herd's productivity. After a period of careful care, the mother cows enter the reproductive stage. Pregnancy lasts about 9 months, and immediately after giving birth, the cow begins a lactation cycle that typically lasts 10 to 12 months. Depending on gender, the calf's journey will take 2 different paths. Male calves are not needed in milk production, so they are usually sold to beef farms, or in many cases slaughtered early to serve the production of premium products such as veal and Parmesan cheese. Famous as an animal full of emotions, the mother cow, when separated from her calf, often runs after it and calls out until she is exhausted and can no longer continue. Meanwhile, female calves are kept and carefully raised to continue maintaining the life cycle of the dairy herd. From the moment a cow gives birth, it officially enters a crucial stage: milking. When milking time comes, the cows are guided into an automatic milking station, where the process takes place smoothly and without stress. Before milking, the udder is carefully cleaned with a disinfectant solution to ensure milk quality. Then, the automatic milking system gently attaches to the udder, simulating the natural suckling motion of a calf. Each cow can produce around 25 to 30 liters of milk per day. On large farms, total daily output can exceed 50,000 liters, enough to fill a small swimming pool. Immediately after being collected, fresh milk is rapidly cooled to about 2 degrees Celsius to 4 degrees Celsius to maintain freshness and prevent bacterial growth. It is then pumped into specialized refrigerated tanker trucks, designed to keep the milk at the ideal temperature throughout transportation to the factory. From there, the milk begins its transformation into the sweet, creamy condensed milk we all love. But that is a story for the next part. As soon as the milk arrives at the factory, it undergoes a strict quality control process. Technicians carefully measure fat and protein levels, check freshness, and conduct tests to detect bacteria or impurities. Every batch is examined with high precision to ensure that only those meeting the highest quality standards proceed to production. If any issue is detected, the entire batch is immediately discarded to maintain the product's quality and safety. After passing all quality checks, the milk is pumped into the factory's closed processing system for pasteurization, a crucial step that eliminates harmful bacteria while preserving the milk's natural nutrients, flavor, and color. The milk is rapidly heated to about 135 degrees to 150 degrees for 2 to 5 seconds, then quickly cooled. This flash heating method effectively destroys bacteria while maintaining the fresh taste and nutritional value of the milk. Next, the milk enters the cream separation stage, where it is pumped into high-speed centrifuges spinning at 10,000 to 20,000 revolutions per minute. The powerful centrifugal force quickly separates the cream milk fat from the skim milk. This process lasts about 2 to 5 minutes, and the fat content can be adjusted according to the desired production formula. The separated cream is then used to make butter or cream, while the standardized milk continues on to the next stage of production. After cream separation, sugar is added to the milk, and the mixture is transferred into a vacuum evaporator to remove about 60% of its water content. If the evaporation happens too quickly or at too high a temperature, the milk can curdle, caramelize, and lose its original flavor. While if it is too slow, the milk will not reach the desired consistency and may be prone to bacterial contamination. That is why the entire process is carefully monitored, maintained at a temperature of 60 degrees Celsius to 80 degrees Celsius for about 30 minutes to 1 hour to yield a smooth, sweet, and nutrient-rich condensed milk. But the sweet journey of these fresh drops of milk does not end there. Part of the milk is diverted for powdered milk production, while the rest continues its path to become the sweetened condensed milk we know today. To produce milk powder, the condensed milk is fed into a spray dryer where it is exposed to temperatures of 150 degrees Celsius to 200 Celsius for 30 to 60 minutes. The high heat removes the remaining water, transforming the milk into a fine powder. After drying, the powder is cooled for about 30 minutes to stabilize its structure and prevent clumping. To create sweetened condensed milk, concentrated milk is mixed with sugar at a ratio of 40% to 50%. In some factories, instead of using fresh concentrated milk, reconstituted milk powder may be used as the main ingredient. Regardless of the source, the production process always ensures that the final product has a consistent flavor and texture. The milk and sugar mixture is transferred into massive industrial mixing tanks, where agitators continuously operate to completely dissolve the sugar and prevent crystallization during storage. After pasteurization, the condensed milk is rapidly cooled to about 15 degrees Celsius to 20 degrees Celsius, using a modern cooling system with chilled pipes and convection fans. This quick cooling process helps stabilize the texture, preventing separation or crystallization during storage. Precise temperature control at this stage is the key to achieving the perfect, smooth consistency. Before reaching the final stage, condensed milk must go through a homogenizer, where it is subjected to high pressure of 150 to 250 bar, breaking down fat molecules into ultra-fine particles. This process prevents separation or clumping during storage, resulting in a final product with a uniform texture, smooth consistency, and rich, creamy flavor. After completing all processing steps, the condensed milk is transferred to a modern automatic packaging line. Specialized filling machines precisely measure and dispense the product into each can or container with exact weight. The packaging is sterilized beforehand to ensure absolute safety. Next, the cans are hermetically sealed using heat or pressure, creating an airtight barrier that prevents bacterial contamination and extends shelf life. To guarantee maximum safety, the sealed cans are then placed in a high-pressure autoclave, where they are sterilized with hot steam at elevated temperature and pressure. This step eliminates any remaining bacteria, allowing condensed milk to be stored for over a year without refrigeration. Finally, the cans are automatically labeled with full information on ingredients, nutritional value, and production date. The finished products are packed into cartons or stacked on pallets via conveyor systems, ready for distribution across the globe. Before the streamlined processes of today's modern factories, do you know where chicken tenders actually came from? Surprisingly, this iconic dish was born from a kitchen accident in the 1970s at the Puritan Backroom Restaurant in New Hampshire, when a chef mistakenly separated the tenderloin, the soft cut of meat beneath the chicken breast. He decided to bread it, deep fry it, and serve it. The unexpected flavor wowed diners with its juicy, tender inside and crispy coating. And from that moment on, the name chicken tenders was born. Although KFC didn't invent the dish, it was the brand that helped popularize chicken tenders around the world. Since the 1990s, they've added extra crispy tenders to their menu, and the item quickly gained popularity thanks to its convenience, easy-to-eat format, and the signature KFC flavor, made possible by a secret recipe that will be revealed in this video. And like every great story, the journey of chicken tenders begins on modern farms, where chickens are raised on a special nutritional regimen to develop thick, tender breasts and tenderloins, perfectly suited to become the star ingredient of one of the world's favorite dishes. Let's explore the world of modern poultry farms, where each baby chick is raised with a perfect blend of advanced technology and human dedication. Here, as soon as the hens begin laying eggs, an automated collection system jumps into action. The eggs gently roll onto conveyor belts, avoiding any damage, and are transported straight to inspection and sorting areas. Every day, thousands of eggs are collected with near-perfect precision, ready to enter the magical stage of incubation. Inside high-tech incubation chambers, where temperature and humidity are tightly controlled, the eggs are carefully rotated by automated machines to ensure the embryos develop evenly. And then, after 21 days of quiet anticipation, the first baby chicks break free and chirp their way into the world, carrying with them a promise of something special. The dream of one day becoming a legendary KFC fried chicken. The chicks are then transported to modern poultry farms, where they're raised in an ideal environment. The barns are spacious, clean, and lined with soft wood shavings to maintain hygiene and support easy movement. Advanced heating systems, infrared lamps, and calming blue lighting are used to maintain a stable temperature and reduce stress for the chicks. Protein-rich feed and clean water are always available through a fully automated 24/7 system. A smart ventilation system controls CO2 levels and humidity, minimizing the risk of respiratory illnesses. After just 5 to 6 weeks, or around 35 to 42 days, the chicks grow into fully developed broilers, ready for the final stage of their journey, heading to the processing plant, where their dream of making it onto a KFC plate finally comes true. When they reach the appropriate age, the chickens are gently gathered using advanced equipment, like robotic caretakers, with soft robotic arms and smart rotating brushes that carefully place them onto conveyor belts. This ensures the chickens line up smoothly and are swiftly guided into transport crates, ready for their journey to the processing plant. Once the chickens arrive at the processing plant, they enter a modern, highly optimized system designed to ensure quality at every step. Before moving on to the next stages, the chickens are given a rest period of 1 to 2 hours to reduce stress and stabilize their condition. After the resting period, the chickens are placed onto automated conveyor systems, where they go through advanced processing stages. Stunning is performed using either low-voltage electrical currents or CO2 gas, helping to minimize stress for the chickens while ensuring the processing is quick and efficient. After the initial processing steps, the chickens move through a hot water bath maintained at a temperature between 50 and 60 degrees Celsius. The purpose of this step is to loosen the feathers and outer layers, making the defeathering process easier and more effective. Here, a set of rubber fingers mounted on rotating shafts acts like skillful hands, using spinning motion and friction to remove feathers precisely and efficiently. Each rubber finger has a specific softness and flexibility, allowing it to reach tougher areas and remove coarser feathers without damaging the delicate skin underneath. Next, the chickens move on to the evisceration stage, where modern machinery is used to open the abdominal cavity and carefully remove the internal organs. This process ensures cleanliness while preserving the freshness and quality of the meat. After the chickens are cleaned, high-precision automated cutting machines swiftly and efficiently remove the feet, head, and other parts. These machines are highly adaptable, allowing them to accurately separate components like the neck, wings, thighs, and breast meat into individual portions while preserving the quality of the meat. These very parts go on to become the beloved fried chicken pieces served by KFC. Next, the chicken breast is carefully separated and handled with great precision. This step requires skill and accuracy, as the breast meat can be easily damaged if not processed correctly. Once separated, the breast is passed through a specialized skin removal machine. This machine operates with remarkable delicacy, gently peeling off the skin without harming the tender meat underneath, preserving its freshness and quality. After the skin is removed, the breast is then carefully cut away from the bone. This stage demands close attention to detail to ensure the meat remains intact without tearing or damage. Sharp blades and precise cutting techniques help extract clean breast meat with no bone fragments left behind. The result is a perfect, tender chicken breast, ready for the next stages of processing. During this process, the most tender part of the breast, known as the tenderloin, is also separated. Tenderloin is a juicy, flavorful, and nutrient-rich cut of meat located just beneath the breast. It is the ideal ingredient for creating delicious, tender chicken, thanks to its naturally tender texture and satisfying taste. Once the tenderloin is perfectly cleaned, it enters one of the most intriguing stages that has fascinated the world, coating with KFC's legendary 11-spice blend. While the exact recipe is kept securely locked in a safe, rumors have circulated about the inclusion of salt, black pepper, paprika, garlic, onion, mustard, and several other secret herbs. It's this meticulous blending and golden ratio that creates an unmistakable flavor, mildly spicy, savory, and irresistibly aromatic. Here, the chicken is coated with the exclusive dry batter, a mixture that has been carefully perfected to adhere evenly to the meat's surface. Depending on the product line, the chicken may be dipped in a wet batter before being coated again with the dry batter, resulting in an extra crispy texture. Finally, each piece of chicken is placed into an industrial pressure fryer, a special piece of equipment that helps maintain a stable temperature and ensures even cooking from the inside out. Thanks to this method, the outer crust turns golden and crispy, while the meat inside remains tender, juicy, and irresistibly fragrant, the signature addictive flavor of KFC that millions of people love. When it comes to chicken tenders, many people often confuse them with chicken strips or chicken fingers, but in reality, they are quite different. Chicken tenders are the tenderloin part, located just beneath the chicken breast, extremely soft, juicy, and naturally long-shaped. On the other hand, chicken strips are simply chicken breast sliced into long strips, more abundant, cheaper, but can easily become dry if not cooked properly. They may look similar, but once you taste them, you'll instantly know which one is the premium version. And when it comes to premium chicken tenders, you simply can't leave out the legendary dipping sauces. At KFC, there isn't just one, but an entire lineup of bold flavors. From honey mustard and smoky barbecue, to rich, creamy ranch and the signature comeback sauce. Mildly spicy, tangy, and seriously addictive. It's the sauce that elevates each crispy bite, turning a simple piece of fried chicken into a memorable experience. So if you think the chicken's good but missing something, chances are you picked the wrong sauce. Chicken tenders aren't just for dipping. Try transforming them into creative and exciting dishes. First, tuck them into a burger for a quick, well-balanced lunch. Looking for a healthier option? Cut them into bite-sized pieces and toss them into a salad, not only adding protein but also boosting your vitamin intake with fresh greens. Another convenient idea is to wrap them in a tortilla for an easy-to-go meal. And if you're a fan of Asian-style cuisine, just slice the tenders and stir-fry them with rice for a flavorful, unique chicken fried rice. No matter how you enjoy them, you'll feel the flavor explosion in every single bite.